Okay, this is lesson 12.2. It's called independent and dependent variables in tables and graphs. All right. So we're going to talk about variables. We're going to talk about independent and dependent variables. There are many situations in the world that have two variable quantities, and one quantity depends on the other. Okay, so there are many situations that have two variable quantities and one quantity depends on the other. Just a reminder of what variable means, okay? Variables are unknown values that can change. That's what variable means. It varies, right? If something varies, that means it changes. So variables are unknown values that can change. And we usually use a letter in the place of the value because we don't know what the value is. It's unknown. So there are many situations that have two variable quantities, and one of those quantities depends on the other. Let's talk about what that means. One of the quantities will be independent, means it can stand on its own. It happens by itself, doesn't need any help, independent. And the independent variable happens first. And usually it causes the dependent variable to happen, and it will happen next. Okay, so that's usually how you can tell which one is the independent and which one is the dependent. The independent variable will happen first, and it will usually cause the dependent variable to happen. Let's give an example. An example is like babysitting. How much you get paid depends on how many hours you work. Okay, so that means money that you get paid and hours that you work are variables. Okay, they can change. Sometimes you work only 1 hour. Sometimes you work 5 hours. So the quantity of time you work varies. It's a variable. And depending on how much you work, that will determine how much you get paid. You have to work first, right? You have to babysit for an hour or 2 hours first. That's the independent variable. And then you will get paid. That's the dependent variable, okay? And those quantities, the number of hours you work and the amount of money you make, can change. All right, that's an example. So let's talk about independent and dependent variables in tables and graphs, okay? So here's a situation where number of hours worked and money earned. We just talked about this example. The number of hours worked is the independent variable because you have to work the hours first. And then after you work, then you get paid. So the money earned is the dependent variable. It happens next. So we're going to label these independent and dependent. Okay. Now we put the independent variable when we do a graph on the x-axis. So the x-axis is here, okay? And we're going to call this hours worked. Okay? Then the dependent variable goes on the y-axis. The y-axis is here, and we're going to call this money earned. Okay? So independent variable goes on the x-axis, dependent goes on the y. Okay? So I'm going to label my scale. And I'm going to give it a scale of 1. So each grid line is going to be worth 1 on the x-axis. But on the y-axis, I'm going to make each grid line worth 10. I'm going to go 0, 10, 20, 30, 40, 50, 60, 70, 80, and 90. So the scale on the y-axis is 10. Scale on the x-axis is 1. Okay, so I have my independent variable, hours worked, and my money earned, my dependent variable. So now I'm going to graph them. If I work 5 hours, 1, 2, 3, 4, 5, I make $40. 10, 20, 30, 40. And that point goes right there. Okay. If I work 8 hours, here's the 8. I make $64. 10, 20, 30, 40, 50, 60, and about 4 is about right there. And if I work 10 hours, I make $80. So here's 10, 10, 20, 30, 40, 50, 60, 70, $80. Okay. And this is the independent variable hours worked on the x-axis, the dependent variable money earned on the y-axis. Okay. This is showing your two variables on a table and on a graph. All right. So let's describe the relationships between independent and dependent variables. There's a couple different relationships the x and the y value can have. So the table shows a relationship between two variables, x and y. It says describe a possible situation the table could represent, and then describe the independent and dependent variables in the situation. So first I'm going to look at the table. I see that x is going 0, 1, 2, 3. So x is going up by 1 every time. I have the y variable. I see it goes 10, 11, 12, 13. It's also going up by 1 every time, 10, 11, 12, 13. So as x increases by 1, y increases by 1 as well. This relationship is called additive. X and y have an additive relationship. That means the value of y is always 10 units greater than the value of x. So this is x plus 10 is 10. X plus 10 is 11. X plus 10 is 12. X plus 10 is 13. So here x is 0, you add 10, you get 10. Here x is 1, you add 10, you get 11. Here x is 2, you add 10, you get 12. So for every x value, you're adding 10 to get y. Okay? The table could represent something like someone saving money, right? That's what this table could represent. So they start with $10. Okay, they start with $10 and they save $1 each week. They save $1 each week or something like that, right? So they start on week 0 with $10. 1 week later, they have $11. 2 weeks later, they have $12. 3 weeks later, they have $13 because they're saving $1 every week. So the independent variable, the x, would be the weeks. So week 0, week 1, week 2, week 3. The y value, the dependent variable, would be the total money saved. Okay, something like that. That's a situation that this table could represent. So each week they're adding $1 to their savings when they start with $10. Okay, so that's an additive relationship where you're adding each week. Okay, let's try a couple more relationships. Here we go. This one says, same thing, show the relationship, describe the independent and dependent, and what's the situation. So we have 0, 0. We have 0, 1, 2, 3. So x is going up by 1 every time again. Then we have 0, 5, 10, 15. So y is going up by 5 every time. So as x increases by 1, y increases by 5. This is a multiplicative relationship, multiplicative. That means we're multiplying. So the value of y is always 5 times the value of x. So 0 times 5 is 0. 1 times 5 is 5. 2 times 5 is 10. 3 times 5 is 15. So you're always multiplying by 5. On the other side, we were adding, right? We were always adding 1, 10, 11, 12. Or I mean, we were adding 10. So we did plus 10 here, we got 10. We did plus 10 here, we got 10. We did plus 10 here, we got 12, right? So 10 plus 1 is 11. 2 plus 10 is 12, right? You're adding 10 every time to x. This time you're multiplying x every time by 5. 1 times 5 is 5. 2 times 5 is 10. 3 times 5 is 15. That's why it's multiplicative on this side. You're multiplying x times 5 to get y. So the table could represent, let's see, let's say you want to give all of your friends 5 pieces of candy. That's what this table could represent. This is a possible situation. So the table could represent how much candy you need to give each of your friends 5 pieces. To give each friend 5 pieces. Okay, and the x would be the number of friends. So if you have 0 friends, you need 0 candy, right? If you have 1 friend, you need 5 pieces of candy. If you have 2 friends, you need 10, and so on. And so the y variable is the total amount of candy you need. Right, the total number of pieces. If you're going to give each friend 5 pieces, and this is the number of friends you have, if you have 3 friends, you need 15 pieces, right? All right, so that's a possible situation. All right, so let's do it with a graph now. The first 2 examples, we did it with tables. Now we're going to do it with a graph. So first we have to read the graph, okay? So it's very important that we look at the scale of the 2 axes. So the x-axis here is going by ones. We've got 1, 2, 3, 4, 5, 6. So just because the 1, 3, and 5 were not labeled, that they are still worth 1, okay? So anytime you see where they've skipped a line, that grid line is still worth a value. Now let's see here, we've got they skipped 1, then 12, they skipped 1, then 24, they skipped 1, then 36. So 12, 24, 36, that's counting by 12s. But remember, there's 1 in the middle, so that's counting by 6s. 6, 12, 18, 24, 30, 36. So the y-axis is going by 6, the x-axis is going by 1. But let's look at this first dot. 1 on the x-axis is 12 on the y. 2 on the x-axis is 24. 3 on the x-axis is 36. So each of these dots goes up by 12. So as x goes up by 1, y goes up by 12. So this is a multiplicative, right? This is a multiplicative situation because x is going up by 1, y is going up by 12. So as x increases by 1, y increases by 12. So this is another multiplicative relationship. The value of y is always 12 times the value of x, okay? So you see 1 times 12 is 12, 2 times 12 is 24, 3 times 12 is 36. So the table could represent how many eggs, you know, eggs come in cartons of 12, how many eggs you have in cartons. And the number of cartons can vary, which means the number of eggs will vary. The number of cartons is going to be your independent variable because you have to have a carton, 1 carton, before you can have eggs, right? So the number of cartons you have, the number of eggs you have depends on how many cartons you have. So the independent variable is the cartons, and the dependent variable is the eggs. All right? All right, so there you go. What you're going to do in this lesson is look at tables and graphs. You're going to identify independent and dependent variables, and then you're going to come up with situations that could go with the table or graph, and you're going to figure out, is it a multiplicative relationship or is it an additive relationship? All right, And remember, the independent variable happens on its own. You don't need to do anything. That happens first, and it causes the dependent variable to happen next. All right.